What's going on? We're back with day 92. Nice job today with the big test. Today we're looking at slope fields, specifically slope fields related to differential equations. So a differential equation, it sounds kind of scary and confusing, but it's really not too bad. It's just an equation that has dy dx equal to something, sometimes in terms of x, sometimes in terms of y. Sometimes in terms of both. So we're just going to kind of on the fly here try a couple of these and creating our own slope fields and how we do that, and then how that'll translate to what we're working on the AP test. So let's say we have this differential equation. Okay, so let's say we have the differential equation, dy dx, right? The derivative is defined as x squared over y plus 2. This kind of stuff looks familiar from back when we did implicit differentiation. So what I want us to do is I want us to sketch a slope field for the following points that I'm going to label in here. So I'm just going to label a hodgepodge of points here. Okay, so at all of these points, I want us to figure out, a slope field is what it is. It's a field of slopes. So what we're doing is all those dots that I put in are points, right? They have an x-coordinate and a y-coordinate. And all we have to do is plug in the x and y coordinate into the dy dx equation to figure out what the slope is, and sketch just a little baby slope of that. So, for example, let's start with the point 0, 0, right? So this point right here, if you follow my cursor, this point right here is 0, 0. Well, what happens if we plug 0, 0 into our equation? Well, dy dx evaluated at the point 0, 0 would be 0 squared over 0 plus 2. Well, that's 0 over 2, which would be a slope of 0. So what I want to do on that little dot there is just sketch a slope of 0. Well, we know 0 slope means a horizontal line, so I'm just going to sketch a little horizontal line right here. Okay. How about the point 1, 0? Well, on the test, some years you have to do this. You have to sketch it in a little space, right? And they probably don't usually ask for this many points, but they'll ask for a few, and they'll check to make sure that your slopes match what they should be. Okay, so at this point right here is the point. First off, you got to make sure you have your x and y in order, right? That's the point 1, 0. So 1 goes in for x, 0 goes in for y. So kind of just doing the work over here, we would have 1 squared over 0 plus 2, and that would give us a slope of 1/2. So my slope for this point, 1, 0, should be a slope of half. Well, if you think about a slope of half, that's a positive slope. It would go up 1 over 2. So I just want to make a slope that's kind of pointing towards this dot right here. Doesn't have to be perfect, but you got to make sure if it's positive, it's got to be positive, right? Half should be a pretty flat slope, so it should look like this. Just kind of, so it's like pointing out towards that other point. Okay. How about the point 2, 0? Well, the point 2, 0 would be 2 squared over 0 plus 2. So that would be 4 over 2. That'd be a slope of 2. Still positive, but a little bit steeper this time, right? And again, the slope of 2, it means up 2 over 1, so I'm going to kind of aim at this point right here and make my slope. The other thing when you're making slope fields is kind of look for things that might help you out, okay? All three of those points that I filled in had a y value of 0. And there are two to the left there that also have a y value of 0. So the denominator has always been 2, okay? And then just think about the function x squared. That's an even function, right? So when I plug in -1 and I'm squaring it, I'm going to get the exact same result as plugging in +1 and squaring it, because -1 squared and +1 squared are both the same. So this point right here should mirror this point right here. Or not mirror, it should be the exact same. I plug in the point -2, 0. That's just like plugging in 2, 0, because I'm squaring my x value. So I should have a slope of 4/2, which is 2. How about the next row? How about the point 0, 1? Well, when I plug in 0 for x, I'm going to get 0 on top. 1 plus 2 is 3. 0 divided by 3 is 0. In fact, every point on this line will have a slope of 0, except for when the bottom of this, the denominator here, equals 0. Well, that's going to equal 0. Let me get this crap out of here. Sorry. Oh, my gosh. Okay. The denominator here is going to be 0 at a y value of -2. Well, that dot isn't on here, so I don't have to worry about it. So all three of these dots should have a slope of 0. All right, how about the point 1, 1? Well, that'll be 1 squared over 1 plus 3. That'll be 1/3. It'll be a slope of 1/3, kind of like 1/2, but even flatter. How about the point 2, 1? Well, that'll be 2 squared, which is 4, over 1 plus 3 is 3. 4/3 is a slope of 4/3. It's like up 1, 2, 3, 4 over 1, 2, 3. So it's like I'm aiming at this point right here. It's a slope pretty close to 1, but a little bit steeper than 1. And I'm just going to kind of quickly finish out the rest of these. The point here is the point 1, 2. So that'll be 1 squared over 2 plus 2. That'll be 1/4. So that'll be a pretty, it's still positive, but pretty flat. The point 2, 2 will be 2 squared, which is 4, over 2 plus 2, which is also 4. So that'll be a slope of 1, heading right at this point right there. Once again, once I completed the right side, because of that x squared, my left side is going to end up being the same. That's not going to be true on every slope field, obviously, but it will be here. So I can just kind of mimic those ones over here. Okay. Down on this row, the bottom row here, where I'm still missing four of my dots, the y value is always -1. -1 plus 2 creates 1 on the denominator. So really, I just have to worry about what x squared is. Well, 1 squared is 1, so this should be a slope of 1. -1 squared is also 1, so that should be a slope of 1. 2 squared is 4, so 4 over 1 is a slope of 4. Pretty steep. And this should be a slope of 4. So we kind of create these slope fields. We can create them by hand by just analyzing the point x, y, and plugging it into our dy dx. To get an idea of what some slope fields look like, here are some slope fields. They can be really big. So they kind of make cool patterns sometimes. Right, just a Google image search for slope fields, you can see what these things look like. Okay. So the ones that have lines have a solution curve sketched through them. So we'll work on that in our next video. Okay. For tomorrow, here's what we're going to be doing. I'm going to have you sketch some slope fields just like this. I'm going to give you some slope fields and make you choose which function goes along with it. So we kind of work backwards. You're given a slope field, and you choose the dy dx that goes with it. Okay? That's it for today. I'll see you guys tomorrow. Two chains. Bye.